Hey everyone, hope you're all doing well. Today we're going to be taking a look at Unit 10 Day 11, which we can see is the surface area of composite figures. So surface area, again, we're talking about how much space is going around the shape on the outside of it. And we're talking about now composite figures. So what we want to be able to do by the end of this lesson is first define what a composite figure is. So that way we know what we're taking the surface area of. We want to be able to derive the formula in order to find the surface area of a composite figure. So figure out where is this formula coming from. And then lastly, once we figure out what that formula is, we want to use it in order to find the surface area of various composite figures. So as our warm-up, we are going to start by writing in the lateral area formulas for the 6 different figures that we've learned about over this unit. And I know today's lesson is on surface area here, and it's asking about lateral area. You'll see why in a little bit. So, as a quick review, for a prism, the lateral area was P times H. And then I'll give some reminders along the way. Remember, P is the perimeter of the base. It's the perimeter, so the measurement going around the side of the base. H is the height of the figure. For a cylinder, our lateral area formula was 2 pi RH, where R is the radius of the cylinder and H is the height of the cylinder. For a pyramid, that was 1/2 times P times L, where again P represented the perimeter and L was the slant height. So that was the measure going on a diagonal along the side of the pyramid rather than straight up and down through the pyramid. That slant height was on the outside. For a cone, lateral area is pi RL, where L is still slant height and R is the radius. For a sphere, the lateral area formula is that there is none. So if you can recall from that lesson, because there are no sides to a sphere, it does not have a lateral area. And then lastly, for a hemisphere, it is 2 pi r squared. So these are all of the different lateral areas that we've used over the course of this unit, and we're going to continue to use those today. What is a composite figure? By definition, a composite figure is a single three-dimensional solid that is made up of 2 or more three-dimensional solids. So it's essentially we're taking 2 or more 3D shapes and putting them together to make one larger overall shape. So a simple example of this might be like a silo on a farm. It's a cylinder on the bottom with a hemisphere on top, but it's one overall figure. Okay, we see another one below here. Figures 1 and 2, 2 separate figures, one stacked on top of the other to create one overall figure that kind of looks like a house. So we're going to start this process of deriving the formula. First question, what type of solid is figure 1 in the diagram? So we can see figure 1, I'll outline here in red, and we can clearly see that that is a pyramid. What type of solid is in figure 2? So that's this one underneath. And hopefully we can see that figure 2 is a prism. So those are the 2 figures. Now the next thing I want you to think about is let's pretend like this 3-dimensional thing was actually in front of you right now. Question 3 wants to know what part or parts of figure 1 would be touchable. If this whole figure was in front of you, what would you be able to touch? Well, just thinking about it, you would be able to touch this front part. You would be able to touch this side. You would be able to touch the left side. And you would be able to touch the back. Okay? So we would be able to touch the front, sides, and back. Okay? What wouldn't we be able to touch? That question wasn't asked, but essentially, we wouldn't be able to touch the bottom part of the pyramid. Okay, it's nudged in between the pyramid and the prism, so we wouldn't be able to touch that. So the only touchable parts are the parts going around the pyramid. In other words, this would be the lateral area of the pyramid. We can only touch those parts of it. Now, when it comes to the prism in figure 2, what would be touchable? Well, we could touch this side, we could touch this side, we could touch the back, we could touch the front. We could not touch the top. The top is covered up by the pyramid, but we could touch the bottom. The bottom is exposed. So we could touch all sides and the bottom. So if we could touch all of the sides, that would be the lateral area of the prism. And if we could touch the bottom, that would be the base of the prism. And so if we wanted to think about everything that was touchable, okay, when it came to the pyramid, we were able to touch the lateral area of the pyramid. When it came to the prism, we were able to touch the lateral area and the base. So what question 5 wants to know is, what would we do mathematically if we wanted to find the surface area, or in other words, the area of anything that was touchable to the overall composite figure? Well, if I wanted to know how much area was touchable on that house, I would take the lateral area of the pyramid, and I would add the lateral area of the prism, and that would get me all of the sides. And then I would just add the base, which is the bottom part of the house. If we add those 3 things together, that's going to give us the total surface area, or how much space is going around the outside of the shape. So, for any composite figure that we'll be working with, our formula is this. Surface area equals LA plus, LA1 plus LA2 plus B, where LA1 just means the lateral area of the first shape. LA2 means the lateral area of the second shape, and B is the base of the figure. Now, obviously, the LA1 and LA2 are interchangeable. Okay, it doesn't matter which one you call which. The important idea here is that we want to determine what 2 shapes we are using. We want to calculate the lateral area of each of those shapes. We want to calculate the base of each of those shapes, and then, of just the one shape, and then add those 3 together. So, we'll take a look at some examples here below. We will start with, example 1. For all examples, find the total surface area of each solid. So again, remember that the surface area is LA plus LA plus B. And I left a bit of a space here because I'm going to do a little subscript of writing what the 2 shapes are. So on top, we have a cone. And then on the bottom, we have a cylinder. And then the base is obviously a circle. So what we're going to do is this. We're going to kind of create like a receipt, for lack of better terms. We have our layout, LA cone plus LA cylinder plus B. What I'm going to do then now is I'm going to go to the top of the page where our formulas are in our notes, and I'm going to replace LA cone and LA cylinder with their formulas. So, lateral area of a cone is pi RL. So underneath LA cone, I'm going to put pi RL plus lateral area of a cylinder. So back up to the notes. Cylinder, 2 pi RH. So underneath LA cylinder, I'm going to put 2 pi RH plus B. Remember that capital B is the area of the base. In this case, the base is a circle. So the area of a circle is pi r squared. What we've done now is we've taken a general formula and we've made it more specific so that it fits the shapes we're working with. At this point, all we have to do is start plugging in numbers. Pi times r, which is the radius of the cone. The radius of the cone we can clearly see is 8, times L, the slant height of the cone. We can see that that slant height is 10. We are now done with the cone portion. Plus 2 pi times r, we want the radius of the cylinder. That's still going to be that same 8 as before. Times h, what is the height of the cylinder? We can see that that height is 11. So now we're done with that portion. Plus pi times r, which is the radius, which is again 8 squared. Okay. So again, after we write the general formula, we replace the LA's and the B's with their specific formula to make it suit our shape. And then after we have the specific formulas, we plug in the values that correspond to the formulas. Once we have that, now we just go to the calculator. You could type all of this in at once. I would strongly recommend that you don't, only because one small error will throw off the entire answer. So what I'd recommend doing is piece by piece. So let's take a look here. If we do a little side by side, maybe. Forget the side by side. We can do pi times 8 times 10, and that gives us 251.3 plus 2 pi times 8 times 11, 552.9, plus pi times 8 squared, 201.1. And now from there, we just add those three things together. Again, if you wanted, you could have put all of that together as one calculation, but just more conservatively to split those up makes things a little bit more manageable. So 251.3 plus 552.9 plus 201.1, 1005.3 is our value. And then our unit is centimeters. And since we are talking about a surface area, centimeters squared. Okay. So there's our final answer. The total surface area of this composite figure is 1005.3 centimeters squared. Okay. Now, I'm going to go a little bit faster here for the second one because I understand these problems seem like they take a while. There's a lot of steps, but as we start to do them more, they actually become much more faster. So, as we look at example 2, we see it's a composite. We have a pyramid sitting on top of a prism. Pyramid sitting on top of a prism. So in order to find the surface area, that's going to be the lateral area of the pyramid plus the lateral area of the prism plus the base. LA plus B. Okay. Now we'll go from general to more specific. The lateral area of a pyramid is 1/2 times P times L. 1/2 times P times L. Plus the lateral area of a prism, P times H, plus B. Okay, B is the area of the base, which we can see is going to be this square here, okay, which is 8 by 8. So I'm just going to put in 8 times 8. Now from here, we can start filling in the specific values. 1/2 times P. Remember, P is the perimeter of the base. So if it's 8 on each side, that's 8 plus 8 is 16, plus another 8 is 24, plus another 8 is 32 if we go all the way around. Perimeter is 32 times L. Well, we don't have the slant height. We have a regular height. Regular height is 3. So remember, just like we've been doing all unit, if we are missing a piece of information, we do Pythagorean theorem in order to find that missing piece. So it's 3 up and down, straight side to side. Remember, the entire side of the pyramid is 8, so we want half of that, 4. And what that'll allow us to do then is our Pythagorean theorem. So just to kind of redraw, 3 up and down, 4 side to side. We want to know what this piece is. 3 squared plus 4 squared equals c squared. 3 squared plus 4 squared is 9 plus 16, which is 25. And we square root both sides. This missing side is 5. That is my slant height. Excuse me. So at this time, we've filled in what we needed to for lateral area of a pyramid, plus perimeter of the prism. Well, it's got the same values as the pyramid, so that's also going to be 32 times the height, which we can see along the side here is 12, plus, I'm just going to rewrite that, 8 times 8. So now we have all of our calculations. At this point, we put in our calculation. 1/2 times 32 times 5. 1/2 times 32 times 5 comes out to be 80. Plus 32 times 12 comes out to be 384. Plus 8 times 8 is 64. And in the end, we can just do that calculation. 80 plus 384 plus 64. 80 plus 384 plus 64. 528 is the value. 528. Our unit is inches, and because it's a surface area, it is squared. Okay. So hopefully we're starting to see this pattern a little bit more. LA plus B. Okay. We'll move along to the next shape here. We can see that we have a cylinder on the left. We have a cone on the right. So surface area will be the lateral area of the cylinder plus the lateral area of a cone plus the base. LA plus B. Now, since we've already worked with both of these shapes, I won't scroll back up. Lateral area of a cylinder, 2 pi RH. Lateral area of a cone, pi RL. Plus B, area of the base. The base is a circle. Area of a circle, pi r squared. At this point, we fill in our pieces. For the cylinder, 2 pi times the radius of the cylinder is 9, times the height of the cylinder is 14, plus, now we go to the cone. Pi times the radius is 9 again, times the slant height, 15, plus pi times the radius, one more time, 9 squared. And now we just go to the calculation. So hopefully you see it's a lot faster once we've got that down. 2 pi times 9 times 14. 2 pi times 9 times 14, 791.7. Plus pi times 9 times 15, 424.1. Plus pi times 9 squared. 254.5. And now we add those three pieces together. So 791.7 plus 424.5 plus 254.5 comes out to be 1470.7, and that's going to be inches again squared. LA plus B. So there's only one example left, number 4. If you feel like you kind of have the idea and you want to try one on your own before seeing it worked out and what the answer is, go ahead and pause the video, try it, see what you come up with. Otherwise, if it's something that you still want to see one more time, thoroughly not getting it, totally fine as well. We'll go through this one step at a time as well. Okay? So step 1, identify the two shapes. On the left side, we see we have a hemisphere, and on the right side, we have a cylinder. So, lateral area of the hemisphere plus lateral area of the cylinder plus B. LA plus B. Lateral area of a hemisphere, that's one we haven't used yet. So if we go back up here, lateral area for a hemisphere, 2 pi r squared. 2 pi r squared plus lateral area of a cylinder was 2 pi RH plus area of the base is a circle, pi r squared. Now we fill in what we know. 2 pi times r, which we see is 8 squared, plus 2 pi times r is still 8, times the height of the cylinder is 22, plus pi times the radius again, 8 squared. And in the end, we put those pieces together. Now, if you want to see what it looks like with everything together at once, that's what I'll do here. So, let me do this. And then we just do it all at once. We just want to be very careful. 2 pi times 8 squared plus 2 pi times 8 times 22 plus pi times 8 squared. In the end, we get 1709.0. Our unit is feet squared. And that takes care of this lesson. So as I finish highlighting here, again, the idea is if we want to know how much space is going around the outside, so for example, if we wanted to paint this or if we wanted to wrap it in gift wrap, something like that, how much would we need? In order to do that, we take the lateral area of the two shapes, which takes care of all of the sides, plus the bottom portion, which is the B, or the area of the base, our general concept, LA plus B, and then we make it more specific based on the shapes we are working with. Okay? So I hope this helps. If at any point you have questions, please feel free to reach out to myself or Miss Flowers if she is your teacher. Always feel free to ask questions. Drop by a Google Hangout if you want to, and we'll do everything that we can to support you. So hopefully you found this informative. I hope all is well with you and your loved ones.